Hey everybody, welcome to the Pre-algebra 10.2 video. We're talking about polygons and quadrilaterals today. Alright, so what is a polygon? Well, it's a closed plane figure whose sides are segments that intersect only at their endpoints. Okay, so closed plane. Closed plane, what does that mean? Well, this is a closed plane figure here because, let's pretend the outer edges here are like a fence, right? And here's the laser pointer, it's like a dog, right? Can't go outside the fence. Okay, so it's closed plane. This would not be a closed plane figure because there's a gap right there, okay? But also it needs to have sides whose segments intersect only at the endpoints, all right? So what we see is this side here, it's a green side, it's intersecting with these blue sides only at the ends, right? Right there and right there. Okay, this would not be a polygon right there because this segment comes and hits this segment here, not at the endpoint. Alright, so let's talk about a regular polygon. Alright, regular polygon is a polygon, of course, in which all the sides have the same length and all the angles have the same measures, okay? So a square is a regular polygon because all sides are the same and you, of course, have 4 90-degree angles there. Now, what about a rectangle, though? Is that a regular polygon? No, it's not. Now, it is a polygon, and this should be a closed plane. I'm sorry, I'm not too accurate with the stylus. But it's not a regular polygon because all the sides aren't the same length, right? Now all the angles are the same. This would be a 90-degree angle there, and a 90 and a 90 and a 90. But again, these two sides, if we're in a rectangle, would be the same, and those two sides would be the same. But all four are not the same. Okay, so another great example of that is your typical hexagon, right? Your typical octagon, so on and so forth. Okay, they're regular if all sides are the same and all the angle measures are also all the same. Alright, so let's talk about convex polygons, alright? So a convex polygon is a polygon in which any 2 points inside the figure can be connected with a straight line that doesn't go outside the figure. That's kind of wordy again. What does that mean? Let's take this rectangle here, alright? I'm going to pick 2 points in here inside this figure. So I'm just going to pick one there and one there. Alright, if I connect those with a straight line, straight-ish, right? That line does not go outside the rectangle, okay? So it's convex, and but maybe that doesn't prove it. Let's pick some more. How about a point there and a point, there? Well, if I connect them again, that line that I use to connect those points does not go outside the rectangle, okay? So most polygons you're going to see are probably going to be like this. They're called convex polygons. Now, what about concave, though? Well, concave polygons are polygons in which a line that connects two interior points runs outside the figure. Okay, so maybe the best example would be that. That's called a chevron, right? And that's should be a little more straight there. Anyway, okay, so if I took 2 points and connected them, like those two, would that line run outside the figure? No. So you probably might be saying, well, isn't that convex? Because wasn't that the definition of those up there? Well, kind of. However, what about these 2 points, though? If I connect those with a straight line, that line goes where? Outside the figure. Okay, so if that can happen, even once on a figure, it is concave. And one other thing up here about polygons in general is that they can't have curves. Okay, can't have curves. And we kind of see that in the definition in that it's a closed plane figure whose sides are segments, right? So a segment is a line connected with 2 points. Now, you can't have a curve that is, made up of 2 points connected with a straight line, or any points connected with a straight line for that matter, right? Even if you had something that looked like that. If you zoom out, you might say, oh, hey, there's a curve right there. But if you zoom in, there's a bunch of segments, right? So if you had that right there, technically that would be a polygon because you have a bunch of straight lines. But if you had a true curve like that, all right, and it was a true curve, and that was the rest of the shape there, that would not be a polygon because you have an actual curve. Whereas here you had what looked like to be a curve, but actually these would be straight lines there. And that, of course, is a straight line as well. Okay, so polygon, no curve. All right, so let's talk about quadrilaterals. What is quadrilateral? Well, pretty simply, it's a four-sided figure. Okay, so there are a lot of shapes out there that can be quadrilaterals. Okay, so the first one that comes to mind is a trapezoid. All right, so a trapezoid has two parallel sides. Okay, so you know, we would say that side and that side are parallel, but these two are obviously not parallel. They would eventually cross. This would be another example. You have those two sides being parallel, but these ones would eventually come and cross down there at some point. The next one that comes to mind is parallelogram. Okay, so a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. Okay, which means that that side and that side are parallel, and they're opposite, but also this side and that side are parallel to each other as well. But we'll do two little ticks over there, because if they were all one tick, it would mean, if it looked like this, we mean all those sides are parallel, which obviously is impossible if you're going to form a quadrilateral. So these two sides are parallel, those two sides are parallel. There you go, parallelogram, hence the name. The next one I can think of is rhombus, R-H-O-M-B-U-S. Okay, and a rhombus looks like this. Okay, and the cool thing about a rhombus is that all the sides are the same length, and they are all, well, I'm sorry, the opposite sides are parallel. So that side and that side are parallel, and that side are parallel. So what does that tell you about a rhombus? Well, if you have opposite sides being parallel, then it's a parallelogram, right? So a rhombus is a parallelogram, except that in a parallelogram, those two sides are maybe like 2 inches and 2 inches, and these two sides would be 4 inches and 4 inches. With a rhombus, they are if it's 3 inches there, it's got to be 3 inches there, 3 inches there, and 3 inches there. All right, and then on to the obvious ones. We have a rectangle, which is a parallelogram. Okay, you have two sides that are the same. The other two sides are also the same length. That side is parallel to that side. That side is parallel to that side. And then the last thing about a triangle is that we have 4 right angles. Okay. Now how about a square? Well, that's a terrible square. We got 4 right angles. We have 4 congruent sides, and these are parallel, and those are parallel. All right, easy peasy, right? Yeah. All right, so what kind of quadrilateral do we have there? Well, let's see. We've got 2 sides that are parallel, and they're both 2.3. Okay. I have 2 other sides that are also parallel, and they are 4. So that would be a what? Well, parallelogram. Parallelogram. P-A-R-A-L-L-E-L-O-gram. All right. How about this figure? What kind of figure is that? Okay. Well, let's see. I didn't give us any measures, but let's see. It's a closed plane figure. There are no curves, so it's a polygon, right? Okay, and it's a convex or concave. Well, it's convex. There are no 2 points that could connect in here with a straight line that would run outside the shape, right? Okay, so it's a convex polygon with one set of parallel sides. We know that to be called the trapezoid. Trapezoid. All right, so next let's talk about the angle measures of quadrilaterals. Okay, so quadra, it's pretty cool because it means what? Well, it means 4, right? Quad 4. All right, so we know that all quadrilaterals have 4 angles. So even if I had something funky looking, kind of like this thing, right? Well, it still has 4 angles, so we would call it a quadrilateral. Okay, and what we need to know is that the sum of the angles in a quadrilateral, the sum of the angles in a quadrilateral is 360 degrees. Okay, 360 degrees. So if I add that angle, that angle, that angle, that angle, it has to give me 360. All right, so let's say I've put in some real angle measures here, or kind of. This angle is 68, this is 90. This angle is 2x plus 1, and this is just x, all right? Now, we want to figure out what the value of each angle is, okay? What is the, the measure of each angle? Well, we know they all have to add up to be, what? 360. So I would take one of the angles and start with x, right? Okay, x. Add that to 68. Add that to, well, again, that means 90 degrees, and then add that to 2x plus 1. And we said that all has to add up to get us 360 degrees. So let's combine some like terms. Well, I have x's there and x's there, so 2x and an x gets me a 3x. Then I have a 68, I have a 90, and a 1. And put all those things together, that gets you, well, let's see, it'll be like 158 plus 159. Equals 360. So we're solving for x. We've got to get it by itself. So let's subtract the 159 from both sides first. Then we've got 3x equals 360 minus 159 is going to be 201. And then lastly, we divide by 3. Divide by 3. 201 divided by 3. That's going to get you, let's see, 201 divided by 3, 60, so 67. 67 degrees, all right? So x equals 67, but we're not quite done. We got to figure out what each angle is, okay? So let's go back up here. Okay, we said, again, x equals 67. So we know that this angle right there is going to be 67 degrees. But this one's a little different, right? I have to plug that 67 in there for x. So I'm going to rewrite that as 2 times 67 plus 1. And 67 times 2 is going to get you 134 plus 1. And 134 plus 1 is, of course, 135. So that angle right there would be 135 degrees. So how can we check our work? Well, let's see. If I add all the angles up, it should equal 360. So 67 plus 68 plus 135 plus 90, lo and behold, wouldn't you know it, equals 360 degrees. All right, guys, there you go. That's all I have for you in this video. Look forward to seeing you in class.